Welcome to the lecture series on object oriented analysis and design. It is true that when we started programming, we wanted to find out a specification, a problem definition, break it into some smaller sub problems called function wise, functionality based, and then try to end up with a set of functions which will have to be put together to make the bigger problem happen. This was traditionally followed and it became a nice term called top down approach. However, as we progressed, we found that it is very difficult to come to the exact task which is what is making the user see. In the top down approach, we are likely to spend more and more time on understanding what is this functionality, how to break it down into smaller functionalities, and then get down to the actual task very late. So, the point is the user, the customer, the stakeholders who are not interested in finding out all that analysis are completely out of focus as to what is the problem that is happening. So, the first count we have taken away the problem from the context. The second count we have completely changed the way the problem is appearing, and on the third count we have moved everything into a set of notations, a set of jargons, a set of language constructs which take away from the people, make us go closer and closer to the machine, because eventually whatever we are doing will appear as a set of instructions that will run on the machine. So, on 3 counts we are moving away further from the context, from the stakeholders, from the domain, whatever we are talking about, and then also from the way we have been expressing. Even though we had nursed the ambition and goal of saying that everything would be as generic as any typical science or mathematical expressions, we are far away from that. We may want to say that it is the architecture that is restricting us. It is a fact that we have to do everything on the machine model which is like this, hardware is like this, that is dictating terms. Whatever be the reason, we have moved away and away and away from all these contexts of science and the problem happening into more and more towards the machine. So, we have gone into the realms of the machine, and the top down approach was giving us a kind of a confidence that at least one way we are able to have a control. Now, what is happening is when we are putting them together, we have spent so much time already, 200% cost overrun, 300% time overrun. We have spent so much time coming down that we cannot hope to link all those simple functions in a manner where we find more time to convince ourselves that yes, it is exactly what we have started with. So, the bottom up has become very weak. They are good ideas, they were always there, but then we were finding it a very weak approach to knit them together, or in many cases we do not have time. We simply forget to put them together. Not only that, as we progress, yes, in the earlier project we have done these blocks, they are all there, but we forget. Each project is a new project, each time we want to start from scratch. Therefore, even though these two approaches for problem solving were known for so many decades, what we have done is, while talking about taking it to the computing platform, we have predominantly been using top down approach. Why is that so, is what we are going to see. This is what it is. So, the top down approach is telling that the problem is right at the top, we keep on building sub problems, sub problems, sub problems. In the bottom up approach, we end up with a sub problem and then we will build it up, saying that under what circumstances this sub problem will be used. So, one way of telling is that to understand what I am going to do, I have to start with the entire studios, then go further and further and further into finding out what I am exactly planning to do, that is click the mouse. This is top down approach. I start with the studio, I will describe to you saying that there are 30 instructions that are necessary for me to click the mouse. Instead you think differently. I want to click the mouse and I know how I am clicking. If necessary, I will link it to the machine, I will link it to the various other things. Eventually I know it is a part of the studios, it is there in the studio, we are all accountable, we are all responsible people, but then my task does not warrant so much of understanding about how to click the mouse. The mouse is here, I can click, I can simply go ahead and use it. Well, you cannot extrapolate the theory, you cannot suddenly talk about Sir Edmund Hillary, who said that he climbed the Himalayas because it is there. The Himalayas was there, Mount Everest was there. It is a well quoted statement which Sir Edmund Hillary made. So, what we need to understand is, we need to make sure that there exists a right kind of a balance between top down and bottom up approach, which is becoming very difficult in computing, because we do not have a dialogue with materials that automatically tells us, and we are plucking everything out of the context, we are casting it in a completely different language. Not only that, we have completely lost sight of the problem as we saw it in the beginning, and we are talking about multi stakeholders, we are talking about different domains. All this was nice in mathematics, all this was nice in science, but then when we start talking about computing, which has to eventually take you to the machine, it was becoming very difficult. So, eventually it became a simple question, which one do you want to do, top down or bottom up? Either you have to choose top down or bottom up. We did not have very many techniques, very many methods when we were doing bottom up earlier on in computing, or as I said, the way we were tackling the problems were so nicely fitting into the top down approach that we got stuck with the top down approach until we ran into the rut, we ran into another dark spell of computing, and by 1990, when people were throwing their hands up saying that we have done our best in this method and still we are tottering, then came the next idea saying that we will pull out some other technical idea, technology idea. Next 5 years, object oriented was the most promising technology idea. That also didn't really deliver, because 96 we said enough is enough, we have done lot of projects, lot of bright minds were attracted, let us take stock, and when we took stock, our success rate of projects was just 16%. Horror stories began in software engineering, because when we start talking about success, on time, within the estimated cost, those are the two parameters, and it simply means that we have overshot on both these parameters by 100 times, 200 times, 300 times, or in other words, no project was ever delivered on time and within the estimated budget. Twice, thrice, 4 times, 5 times, the time estimates, cost estimates keep on escalating, and still there is no solution in sight. It is not that we did not have good concepts, it is not that we did not have good principles, but then as the way we started understanding this new idea called computing and computer programming in a business context, we found that top down approach is better, because we will have somebody telling us this is how we are going to do. The algorithms are designed using two approaches, that are top down and bottom up approach. In the top down approach, the complex module is divided into sub modules. On the other hand, bottom up approach begins with the elementary modules and then combine them further. So, the bottom up approach is we are having this many things ready made, you see what you can do by putting them together. A good example for bottom up approach is the Meccano. Earlier on, when we were talking about this, Meccano was a toy game. Several of our summers we were using that game. It was very affordable. Much later it became Lego toys. They have some standard components. Using those components, you can make about 50 artifacts. Sometimes it is like a cart, sometimes it is like a car, sometimes it is like that. Meccano was metallic, and it required the real screw, which was more like an engineering exercise. The Lego and other kind of models which were replicating were out of plastic. You can simply put them out together. So, Meccano was something which was considered a bit of a harder game, even though it is a game. So, you have about 50 to 60 components, they are ready made, they are there. What can you do with these 50 to 60 components? There is a chart, ready made chart, that tells that you can attempt any one of these. It used to be a good idea, it used to be a good game. Take an object, who will do it faster? Who will make it happen faster? Who can put them together faster? It was a nice game, it was all about metallic, you have to really use the screw and then do the work. Now, that is a good example of bottom up. But then please understand that in the bottom up approach, we expect that all those components or parts are well determined, well thought of, well provided. In the first iteration, it is ought to be top down is what we have been always advocating. Eventually, you will end up with some components which you will build and keep. That is how it is. So, there are two ways of problem solving, top down and bottom up. We cannot completely get rid of top down. At the same time, since we have started with top down, we are not inclined to carry forward with top down whatever happens. Where is the scope? Is there a technical way in which we can blend these two? The first technology solution is object oriented analysis and design. So, we have been talking about top down analysis and design, bottom up construction. The object oriented analysis and design methodologies, methods as we study in the subsequent lectures will allow us to put together existing components to make the solution faster, maybe better understood, because you have already done it. You have already done it earlier, it is there, you just put it across. So, it is some kind of a plug and play in software which we thought can potentially happen. We can always think of software components which can be procured, kept like in a Meccano or a Lego toy, and then make sure that we will build them together. So, this is how we started doing the problem solving, and thanks to the technology support, we are not saying that it is always top down versus bottom up. We will see where they can blend together. A complicated algorithm is split into small parts called modules, and the process of splitting is called modularization. Modularization significantly reduces the complications of designing an algorithm and make its process more easier to design and implement. Modular programming is a technique. So, the point here is that what we want to communicate is we will break it up into functions, but those functions cannot be one liners, two liners. They should be a sizable function, or put together a few functions and call it a module. So, in theory nothing prevents us from calling that every line in your syllabus object oriented analysis and design is a unit. What prevents us from doing it? Every term is a unit. So, we want people who are writing up the syllabi to concentrate a bit more and say that these topics are related as unit 1, put them together, it makes some better sense. Otherwise, they will be several topics. Let us suppose each unit is having 15, you can have 75 units. So, that is what we say when we are doing the lectures, we talk about topics. When we are writing the syllabus, we talk about units. It is a way we train ourselves as to see how the topics get related, how the modules form. Well, you can always tell that what is the need for all these unit 1, unit 2, unit 3, you will simply put everything and call it OOAD, object oriented analysis and design. It is a monolithic idea. Well, we somehow think that we will not be able to manage that entire chunk together. We like to have well structured. So, in summary, the structuring of our solution, the way we look at the syllabus makes plenty of sense when we are discovering or uncovering the syllabus. It happens. When we are doing the lectures, it will be topics that we are choosing. So, this is how we think that is our natural way of working. It is true in the beginning, we will ask the same question, all right, we will want, do you want to have a subject, object oriented analysis and design? What are the reasons? Why is it fitting? What are the various things that you should think of while including a subject? Then we will start building the same exercise, unit 1, unit 2, unit 3, nice modules, different topics, textbook references, objectives, outcomes. The structure is obvious. Once it is structured, what is the advantage? Anyone who is reading, irrespective of whether the person who is reading is actually knowing the subject or not, thinks that it is a constructible idea, one after one we can put together, it makes a very cogent syllabus, a program happens. That is how it is. The content in the functions are cohesive and there exists a low coupling between the modules. Ideally, unit 1 should have a separate heading, that is a meaning. Why should a unit 1 have a separate heading? There is a meaning for that. Top down breaks the massive problem into smaller subproblems, submodules are solitarily analyzed. The module is so nice a concept that you can throw it away if you want, it is not going to impact anything else. If you want, you keep the entire module, if you do not want, you can keep it aside. Module is more important because if a fault occurs in the module, it is limited only to the module. Communication is not required in top down approach because it speaks it for itself. There is no need for a horizontal communication. These modules talk to these modules, implicit. Contain redundant information. Structure procedural oriented programming languages follow the top down approach. For a good number of years we were stuck with structured programming, which was very nice, very well developed. Even today it is true that without structuring our solution we can't move forward in any other programming methodology, paradigm or technology. Structure remains our number one strength. We tried, but then we got obsessed with the structure and later on we realized that simply because we have got obsessed with the structure we ran into more difficulties, but then we can't help it because it is not going to work only for me in my presence. Even if I vanish, even if you put it on a different machine, the solution should work. Module documentation, test case creation, code implementation and debugging, all these are nicely facilitated by the top down approach. Module documentation, test case creation, code implementation and debugging, everything is very nice. Then came the bottom up, it solves the fundamental low level problems and integrates them into a larger one. So, we keep on telling that analysis allows us to break into smaller pieces, but there is nothing from within the domain which tells me this is how you should put them together. It is easy to break them and scatter them into 50 pieces, but what makes them come together, what makes me put them together, difficult to understand. So, bottom up was giving me that provision saying that however the modules are developed, wherever the modules are developed, we know that this is the status of the module, we know how to put them together. To an extent, yes, it helps in the technical solution called object oriented, which has a good theoretical backing. We can have some proofs arising in terms of what exactly is the thing that has happened. At least we are able to attest to a working solution, examine what data is to be encapsulated and implies the concept of information hiding, needs a specific amount of communication. So, in the last lecture there are three major aspects of object oriented programming, namely data encapsulation, polymorphism and inheritance. These are the three features of object oriented that makes us think that bottom up is possible. So, even if I want to know who made this mouse, you can tell no sir, it is not necessary for you to click. You can go further, we can go further and find out who made this mouse, what is the brand, when was it purchased, what is the thing that is going to make it happen, when was it last serviced. I can have 20 questions on finding out just to understand click. Where is the end to top down? The big question mark. So, the bottom up approach was giving us a facility that this is the kind of a thing. We halt here, we produce one more, we produce one more, we put them together. So, these 5 to 6 things are able to solve a bigger problem. Needs a specific amount of communication to tell that yes, this much it is, data encapsulation is here, you can't know anything more than how to click the mouse. Redundancy can be eliminated, object like things are already known, they are found out. Object oriented programming languages like C++, Java follow the bottom up approach. Bottom up approach has become feasible, readily understandable after we took to a paradigm shift called object oriented. The top down approach is implicit in this. We are not again doing top down versus bottom up. How much top down, how much bottom up, when can they blend together? Is there a technical support that gives me an assurance that you are on the track, you are not on the track? Technical simply tells that yes, all of us independently can ask the same question, all of us can independently arrive at more or less the same conclusion. Testing has become something which we have been talking about. Why? Because we now become anticipatory. For anticipating what happens, otherwise we are quite contented with debugging, fault analysis. Now testing has become a nicely defined phase in software development. It is not merely test case creation. Testing as a phase has now developed. 49 different types of tests are there. We also know that only 33% of the code written can ever be tested. Top down approach. The top down approach basically divides a complex problem or algorithm into multiple smaller parts. This is what we have been doing all along. The bottom up approach works in just opposite manner to the top down approach. Initially it includes the designing of the most fundamental parts, which are then combined to make the higher level module. So we challenged ourselves, can you find out what are those core set of modules, parts, which are absolutely essential to build most of the code? Very quickly can you build that? So these are all the challenges. We have been talking about the right blend of top down and bottom up, which is very necessary. The top down approach is like this. These modules are further decomposed until the resulting module is a fundamental program, essentially be understood and cannot be further decomposed. Is it possible like that? Can I reach a point saying that it cannot be decomposed further? These are not answered in the approach ourselves. It is a team that decides. Yeah, we draw a line here. We do not want to decompose this problem any beyond. The square root is square root. Let us not talk about getting coefficients as another module. Quadratic equation is just like that. So we know that this is the granularity of the module. It should have this many certain things. So what we did was we created two terms. As we progress in the subsequent lectures, we will know cohesion and coupling. Cohesion is about the granularity of the module. How many things and how are they coming together in a module? That question is answered by cohesion. How these modules are interconnectable, in how many ways you can interconnect, they are called coupling factors. So by addressing that simple tussle we had, top down versus bottom up, in this manner we have shifted our idea of analysis and design to two important terms called cohesion and coupling. We maximize cohesion, minimize coupling. That is how we keep talking about, and a language or a paradigm that is helping us do this in a very nice manner is object oriented analysis and design. The testing is accomplished using the certain low level functions. Key differences: top down approach decomposes the large task into smaller subtasks. Now task is something which requires more clarity than a function. Task is operational. Task is telling to go transactional, just go ahead and do it. I am tasked with doing this lecture, whereas one of my functions is to do lectures. I am doing so many things. Right now I am tasked to do this lecture. I am not doing anything other than this lecture, even though I am functionally called in to do 2-3 other things. Each submodule is separately processed in a top down approach. The different modules in top down approach do not require much communication. The procedural programming languages are like this. A summary: the top down approach and bottom up approach are the algorithm design methods, where top down is a conventional approach which decomposes the system from high level specification to low level specification. On the other hand, the bottom up approach is more efficient and works in an inverse manner, where the primitive components are designed at first, then proceeded to the higher level. The top down approach emphasizes on the isolation of submodules, signifies the low coupling between the modules, while ignores the identification of the communication and reusability concept. Now these are all the ways and means in which we have simply come out of that choice which we have to make, top down or bottom up. At the same time, we do not want to keep on confusing ourselves that when shall we go bottom up, when shall we go top down. So we created some nice set of terms: maximize cohesion, minimize coupling, and then we talked about ways of quantifying cohesion, ways of quantifying the coupling factors, and then talk about other terms like what is the communication that we have to do, how many messages have to be transacted, what is the kind of a reusability which we are talking about. So, this is how we have been doing both top down and bottom up together using a higher level set of terminology, and they find a ready reflection in object oriented analysis and design and the paradigm called object oriented paradigm. By saying so, I am not indicating that we are debunking the earlier structured programming paradigm. It is there, it is also necessary. We should understand early lessons that we began, like we said in the very first lecture, puzzles, then to problems, then to programs, and then to software. As we progressed in that direction, we have understood some very valuable lessons that gave us the stability to tell that this is not so much esoteric. The machine is not taking away everything. The machine is only asking us to tell that bring it out of the context, make it as independent as possible of the problem, the stakeholders, the domain, convert it into a completely different language which makes it easier to go to the machine at the earliest. So, outside of it, it is not doing anything. It has met with initial skepticism, and it is the top down approach that gave us the best way of talking, best way of working in a manner where we stabilized the idea of computing, computation, computing platforms, programming, or in other words, the top down approach remains the number one methodology we used to establish that there is something called a field software engineering definable. That was nicely documented by 85. By 90, we have realized that even after all this, we are running into the same difficulties over and over again. A technical solution emerged called object oriented technologies, object oriented analysis and design. Next 5 years, 90 to 95, we were talking about only object oriented programming as the next best bet. There is no silver bullet in software engineering, there is no silver bullet in the way we are working, but then the most promising spell of 5 years, and then once we started doing object oriented properly, we got an idea about the project, we found that our success rate is dismal 16%. It is not that object oriented failed. It is the fact that we could not adopt this blending of top down and bottom up in a manner where each time we show good progress on cohesion, simultaneously good progress on coupling, they are mutually contradictory. Cohesion wants everything to be put together, coupling wants as many components as possible to be identified separately. So, the tussle between cohesion, coupling, communication, how much of communication, reusability, all these ideas became so intricate that we kept on debating over and over again that object oriented requires a completely different way of thinking. It cannot be so much dependent on this idea called top down, bottom up, but they are necessary. That is how we learnt it in the first place. So, what is the way out? As we progress in the next subsequent lectures, we will quickly see that there have been certain good pioneering efforts in telling that this is a method. You please follow this method, you will understand where to use top down, where to use bottom up, where cohesion helps you, where coupling helps you, what is the kind of a communication you should define, what is the reusability, all the things that we are talking about, data encapsulation, polymorphism, inheritance, all of them appear, but this method is good enough for this purpose. So, we talked about object oriented methods. Please understand, this entire series of lectures is not to create a dichotomy top down versus bottom up, but to use this idea called object oriented. It is a very powerful idea, a very good paradigm which tells us that use them in a manner where they blend at a level of cohesion, at a level of coupling, a level of communication, a level of reusability, higher order concepts which make us think that they can nicely come together and we win on bottom up, we win on top down. Thank you. We will see again in the next lecture.